I often get the question, how can I produce Dolby Atmos in an environment that doesn't really have a sophisticated speaker setup? Certainly not one that a professional Dolby Atmos studio would have. And the answer to that question is relatively simple. We can do that through binaural head tracking. And this is what we're going to do today. We're going to turn a digital audio workstation, in our case Ableton, into a production station for Dolby Atmos. We're going to monitor it in 9.1.6, and we're going to monitor it in a way as if those 16 speakers were all around us. So let's get started. But first of all, hello everybody. In case you're new here, my name is Michael Wagner. I'm a digital media educator with more than 30 years of experience in higher education. And on this channel, I talk about digital media, game design, and spatial audio. If any of those topics interest you, I invite you to subscribe or join my Discord community. That link is in the description below, or there's also a QR code here somewhere. Before I get started, two quick disclaimers. The first one is that the plugins that I'm going to use today were provided to me for free. Some of them are pre-release versions. However, this is not a sponsored video. Nobody has seen this video before. And as always, everything that I'm going to talk about is strictly my own opinion. So nobody told me what to actually say. The second thing is that I'm going to work on a Mac today. And when I prepared for this video, I originally wanted to create this video on both Windows as well as on Mac. So kind of going through the Mac setup first and then going through the Windows setup. However, as it turned out, that would have been way too long for a YouTube video. So I decided to split it up. So today I'm going to talk about the Mac setup. And next week, most likely, I'm going to talk about the Windows setup. However, if you're a Windows user, most of the things that we're going to do today are also applicable to the Windows setup. There are just a few things that you need to do differently. And I'm going to actually point those out in the video today. So if you're a Windows user, you might still find it useful to watch this video. However, be aware that there's an additional video coming up that specifically targets the Windows setup. And with that being said, let's get started. Now, I'm going to work with Ableton today, but what I'm going to talk about works on pretty much any digital audio workstation. As long as it can load plugins, you should be fine. Now, I usually keep my projects super simple. In this particular case, I decided to even go simpler than I normally do. And the reason for that is because I wanted to make sure that we have a good sense on how the spatial positioning of the sound works in our binaural setup, so that we have some understanding about how accurate actually our images that we're getting. So I decided to use a signal that is completely dry, and we're actually going to use it in a mono way. Now, in order to make it a little bit more interesting, I kind of added a little MIDI loop. So let's just have a brief listen on how that sounds. So once again, nothing particularly special, but it should be enough for what we want to do today. Now, the first thing that I need to do is I need to turn the setup into a Dolby Atmos capable setup. And there are actually a couple of different ways on how I can do that, especially on a Mac. Now, what I'm going to do today is I'm going to use Fiedler Audio's Dolby Atmos Composer, simply because I think it's the most convenient way to do things. And most importantly, it works on every digital audio workstation out there. So if you are on Studio One or FL Studio or Reason or Bitwig or whatever, you can follow the exact same steps that I'm doing here, and it should work just fine. Now, I already did an in-depth review of Fiedler Audio's Dolby Atmos Composer last week, so I'm not going to do that today. If you're interested in how it works exactly, I invite you to watch the video. I'm going to leave a link in the description below. So what I need to do is I need to first put an instance of the Dolby Atmos Composer on our master bus. Now, since I'm on a Mac, I can do that either with an audio unit version of the Composer or a VST3 version. Now, if you're on a Mac and you have access to audio units, I recommend using the audio unit version. That seems to be a little bit more efficient and also a little bit more stable. However, in order to demonstrate that it works just as fine with VST3, I'm going to use VST3 today. This also because there are some digital audio workstations out there that don't really have access to audio units. So if you're on one of those, essentially it just works. So let's go into our plugin list and let's take an instance of Fiedler Audio's Dolby Atmos Composer and let's drop it on our master bus. And this will essentially open up the Dolby Atmos Composer. Once again, I'm not going to talk much about how that actually works. I already did that last week. Video link in the description below. The second thing that I need to do is I need to put an instance of the Dolby Atmos Beam plugin, which will be responsible for beaming the audio from our track into the Dolby Atmos Composer. I'm going to put an instance of that plugin onto our track. This is the Streamy Bell track, which is essentially a very simple operator instrument in Ableton. So let's put an instance of Dolby Atmos Beam into our track. And as soon as I do that, you might notice that here, if I look at the CPU load, you will notice that this actually jumps. Now, if you see that for the first time, you might be a little bit scared, thinking that this actually kind of requires a lot of processing power. However, that processing power comes primarily from the binaural rendering. So if we go into the master track and we open up the Dolby Atmos Composer here, by default, it is set up to render in binaural mode through headphones, and this binaural rendering actually takes a lot of CPU. So if I turned it off, for example, right, then essentially I see the CPU load drop. It's still quite a bit. So be aware that you will need a quite new system in order to be able to do that. However, it's not as dramatic as it seems. So what we're going to do is we're actually going to not listen to it through headphones. We're actually going to listen through it through our virtual speaker setup. And that essentially will require a lot less resources on the Dolby Atmos Composer side. We will need to have some binaural rendering in addition to that. But on the Dolby Atmos Composer side, the efficiency should actually be quite fine. So let's turn that back on to binaural, just so that we hear something. And let's maybe turn the speakers off for a second. And let's see if we hear an audio. So what is happening now is that the audio track is sent with the Dolby Atmos Beam plugin into the Dolby Atmos Composer, and the Dolby Atmos Composer essentially forwards it into the Dolby Atmos bed. And because it's just a stereo signal, it's going to be forwarded into the left and right channel. Now, a couple of things we're going to do here in order to make that a little bit more interesting. The first thing is I'm going to switch that over from 7.1.2 into 9.1.6 because why not? Dolby Atmos Composer allows us to do that, and that essentially will change the bed configuration into a 9.1.6 bed. And what we're going to actually do is we're going to listen to that in a virtualized 9.1.6 environment. And then I'm going to go into the Dolby Atmos Beam plugin on our little track here. And what I'm going to do is I'm going to move the speakers out of their position a little, because at the moment they are located at left and right speaker positions, which essentially is not particularly interesting. So let's just move the speakers out a little and then maybe kind of change the elevation slightly. So that we have a little bit more of a three-dimensional nature of the sound. And if we play the sound now, so let's just kind of go back here and let's go into the master. I essentially see that I now have action on most of the 16 channels. Obviously, the backhead speakers are not active yet because the signal is in front of me. So this is all super nice and super interesting, and because it is binaural, you get some sort of a three-dimensional impression. However, that impression is not really fully immersive, and the reason is very obvious, because the speaker setup that is sort of simulated through the binaural rendering is sort of really kind of connected to my head. If I'm moving my head, I'm essentially moving the entire speaker setup around with me, and I'm not really getting a fully immersive impression. Now, in order to be able to actually become fully immersive, what I need to do is I need to actually have a setup where I'm virtualizing the speakers and then essentially tracking my head position and feeding the audio signal into my headphones in exactly the same way I would hear them in a real kind of 9.1.6 speaker setup. And this is essentially what we're going to do now. Now, the first thing that we need to do in order to enable that is we need to add a plugin that can actually take a 9.1.6 signal and convert that into binaural with the use of head tracking. And there is one out there that can do that. And this one plugin is called Virtuoso. It's currently available in early access for a fairly reduced price. So if you're interested in that setup, you might want to kind of look at that. Now, there are really two ways on how you could use Virtuoso in a setup like that. You could either use it as a plugin within your digital audio workstation, or you can use it as a standalone version. Now, because we're working with a stereo digital audio workstation, the plugin option isn't really available to us. What we really want is we want that plugin to take in all 16 channels and then essentially convert these 16 channels into a binaural signal. However, we can't really do that, or not least easily, within Ableton, because Ableton, once again, is not really capable of handling 16 tracks. So we need to run it externally. And the nice thing about Virtuoso is that it has a standalone version. So we're going to use the standalone version here, and then we're going to route the audio from the Digital Audio Composer into that standalone version of Virtuoso. So let's open up the standalone version. So let's see. Here we are. That's probably going to take a bit until it kind of is fully open. And once it's open, we will see the speaker setup. Now it's going to open up currently, and once again, this is early access. This is an early access version, but you can actually buy that now. So you can actually get access. You can get early access to that plugin right away. So a couple of things that you need to do in order to get that going. I might actually do a separate video on Virtuoso because there's so many things that we can set here, and we're not going to use everything in this particular video, but a couple of things that we're going to do. The first thing is we want to actually monitor that audio in 9.1.6 format. So the first thing that we need to do is we need to change the input configuration to Dolby Atmos 9.1.6. Now there are different options for 9.1.6, and these different options depend on the type of speaker configuration that you want to have. In particular, the arrangement of the kind of speakers behind you. So if I'm going to the option 9.1.6a, I essentially see that the back speakers are actually quite far apart. If I'm choosing 9.1.6.b, for example, these will actually kind of move together a little. And I found that the B version actually works better for what we're doing today. But once again, just choose whatever feels more appropriate to you. It doesn't really make any difference. Both are fine for Dolby Atmos. Now, the next thing that we need to do is we need to route the audio from the digital audio workstation into Virtuoso. And there are a couple of things that we need to set. So the first thing is let's set these settings on Virtuoso first. So we're going to go into the audio settings. And in the audio settings, I have the output set to my interface, so that's fine. And then essentially I need to select an input. And there are a couple of different ways on how I could go about that. Well, essentially what you need is you need a virtual device that can route 16 channels from one application to another application. And on a Mac, there are a couple of different options that you have usually. And I actually have a few of those. So what we could do, for example, is if you have the Dolby Atmos bridge, you could actually use that, the Dolby Audio bridge. It works just as fine. Another option that I have here is the immersive audio bridge. That is actually an audio bridge that comes with the Embody immersive mixing studio. I'm going to leave links to those in the description below. So if you have that, that's an option. If you have Pro Tools installed, you can use the Pro Tools audio bridge. That's fine as well. But what I'm going to do is I'm going to use a loopback device. And the loopback is actually a really nice little application that allows you to create virtual devices in any way, shape, or form you need them. So I'm going to choose that. And in order to show you essentially how that is routed, let's just open up loopback. Where is loopback? Here we have loopback. And you can essentially see that this is just a pass-through device that takes the 16 input channels and passes them through to 16 output channels. And that should be fine on the Virtuoso side. So now we need to make sure that the audio is also sent from the Dolby Atmos Composer into Virtuoso. So let's go into the Dolby Atmos Composer and let's configure that correctly. Now, the first thing that we need to do is because we want that to be actually monitored in 9.1.6, we need to turn the speaker setup to 9.1.6. And then we need to turn off the headphones. Now, if you are working with the audio unit version, actually kind of it turns it out automatically. I'm not quite sure why it doesn't do that with the VST3 version, but in any case, I think it's a good practice to just turn it off to make sure that we are not mixing the regular speaker signal with the binaural signal. And then we need to change the external output. And this is actually the main reason why we are working on a Mac differently to in Windows. On a Mac, you can actually kind of use these virtual devices to route the audio out of the Composer into Virtuoso. That option is not available in Windows. In Windows, we will need to apply a couple of hacks and tricks in order to make that work, but it will work in exactly the same way. Once again, if you're interested in the Windows version of this video, I'm going to do that next week. But here, I'm just going to use the loopback device. That was the one that I essentially already selected in the virtual in Virtuoso in the binaural renderer. So let's kind of change that. And let's play the audio. Now I should actually hear everything through Virtuoso. So let's just open up Virtuoso here and let's put that maybe here on the side so that we can see both at the same time. And let's just play our audio. And that should now come in Virtuoso. So far so good. Now there are a couple of things that we need to do. The first thing is that you might have noticed that I now hear the audio signal twice, and that is because the Dolby Atmos Composer sends the audio signal into Virtuoso, but at the same time Ableton also forwards the stereo audio to the output. So what I need to do in order to make that actually work, let me just close the Dolby Atmos Composer here. I need to make sure that no audio signal leaves the master here. So the easiest way to do that is by simply adding a utility plugin, and let's just go add a utility here, and let's set that to mute, and that makes essentially sure that no audio kind of leaves the signal here, that leaves the digital audio workstation here. And let's open up the Dolby Atmos Composer again, and let's play that again. And it's now no longer doubled. But the second thing that I need to do is, and that is not immediately apparent, but if you play around with it, you will notice that fairly quickly, and that is that the channel configuration or the channel order that goes out of the Dolby Atmos Composer does not really match the channel order in Virtuoso. In particular, the ordering of the left wide and right wide speakers is a little off. So in the Dolby Atmos Composer, they leave on, I think that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. However, Virtuoso expects them to come in at 5 and 6. So what we need to do is we need to remap those channels. Now, fortunately, that is actually fairly easy to do in Virtuoso because it has this little matrix setting here. And this matrix setting tells me what input goes to what speaker. In our particular case, and once again, this is something that you need to figure out best. The way I did that, it was through trial and error. So I went into the Beam plugin, position sound, and then kind of checked out where the sound actually goes. But here I'm just going to show you how to do that. So once again, the Dolby Atmos Composer is sending the wide speakers, the left, right, and the right speaker on channels 9 and 10. And the Virtuoso is actually expecting them here. So what we're going to do is we're simply going to select, input 9 goes to speaker 5 instead of input 5, and speaker 10 goes to the speaker number 6, and then essentially the remaining ones are just moved over a couple of spots, and the final 6 are just fine the way they are. So this is sort of the setup. Once you have set that up, you might want to save that. Unfortunately, Virtuoso at the moment at least doesn't really have presets, but what you can do is you can go into the options and then essentially set save current state, and that will also save the settings that you have here in the matrix. However, be aware, if you switch the input configuration to another input configuration, at least in the current version of that plugin, it will forget what you did here. So that's something that you need to be aware of. So once we have done that, the speaker configuration in Virtuoso will match the speaker configuration that is sent out by the Composer plugin. Let's just play that sound again. So the next thing I want to do is I want to simply see how the three-dimensional impression is that I'm getting. And in order to do that, there are a couple of things, once again, that I'm going to do. The first thing that I'm going to do is I'm going to switch that signal into a mono signal. And the reason I want to do that is so that we have a clearer picture on where the location of that particular signal comes from. So let me just kind of go into the track itself, and let's kind of turn on that mono knob here. That will change that into a mono signal. So if I'm playing that now, I should actually hear that in mono. So I essentially see that coming in at the center channel because currently the signal is located at the center. So the next thing that I'm going to do is I'm going to kind of animate that, and in order to kind of really demonstrate how the three-dimensionality works, what I'm going to do is I'm going to simply rotate that sound around in a rather slow manner. So let's automate the azimuth, and that will make sure that the signal actually moves around me. So let's go into the Beam plugin again, and in the big Beam plugin, what I want to do is I want to simply automate that azimuth angle. After touching that, let me go into the automation settings here, and I should already have the azimuth here selected because I just touched it. And then let's add a point here, and then let's add a point up here where we are. Yep. Oops. So a little fiddly, sorry. So here we are, and then let's see how that actually kind of works. And what I should see now is this signal essentially moving around 360 degrees, and I should get some impression that I actually have movement here. So let's just go. So it's now coming back from that side. And it's moving around me. If you hear something that's off, when you do that, then most likely you need to kind of make sure that the speaker configuration is set correctly in the matrix. It's going back until it has completed the step. And maybe we kind of move that up in the elevation a little in order to kind of get a little bit more action on the height channels. So if I'm going into the input settings here, I essentially see that the height channels are now active, and they're going to come in as the object is moving around. Right. So I moved it around rather slow on purpose so that I get a little bit of better impression on how that actually kind of moves. But this is already pretty nice. However, a lot of people complain that this is not fully immersive, and that is fairly obvious because even though I have a 9.1.6 speaker setup that I've virtualized and simulated in my headphones, the immersion is kind of broken by the fact that this speaker setup kind of moves around with my head. It's sort of glued to my head, and I don't really want that. I want the speakers to be fixed and then react to the way I move my head. And in order to do that, what we're going to do is we're going to add head tracking to what we have so far. And if you've been watching my channel for quite some time, you know that I did a lot of head tracking videos. I haven't done for quite some time, so this is long overdue. So let's get into head tracking. Now, the head tracker that I'm going to use today is the Supperware head tracker. Now, I have made a couple of videos about that, and I'm probably going to leave at least one link in the description below, but this is one of the really nice ones. So if you're interested in head tracking, I think this is a really excellent solution. Ben Supper, who developed that tracker, is also very active in making sure that the software is continuously updated. So this is actually one of the nicest ones, and it's also very stable, so it doesn't really drift that much. So the first thing that we need to do is we need to take that head tracker and we need to affix that to the headband. If you have a headphone where you can open up the padding, then you can actually put that inside the padding. I've done that in some of my previous videos, but here I'm just going to kind of put that with little rubber bands on my headphone and fix it that way. Now, since this is a little fiddly, what I'm going to do now is I'm simply going to take a second and I'm going to come back once I've kind of connected that to my headphones. And I'm back. I've added the head tracker to my headband. Now, the head tracker itself comes with these little clips, and you simply need to provide your own rubber bands, at least for my headphones, because the ones that were included were kind of too small. So I kind of just used some regular rubber bands and connected it that way. And we are now ready for head tracking. We obviously also need to connect that to our device, to our laptop. So in my particular case, I'm connecting that to my MacBook here. So let's just go over here and let's connect that. And with that, I'm now kind of connected. So the next thing I need to do is I need to open up the Bridgehead application. The Bridgehead application comes with the Supperware head tracker, and it is responsible for converting the signal that comes out of the head tracker into OSC messages. And these OSC messages can then be read by whatever application is taking advantage of head tracking. In our particular case, it's going to be Virtuoso. So let's open up the Bridgehead application, and here we are. And here, if you open that up, you should already see some activity. Now, in my particular case, this is actually moving incorrectly. And the reason for that is because I need to change the chirality of the head tracker. So make sure that all the settings are set correctly. So in my particular case, I actually have the cable on the right. So let's kind of move that to cable on the right. And that should now be correct. Now it's still kind of off a little. So if you double click on that, it will actually reset. And that works now correctly. The next thing we need to do is we need to make sure that the OSC messages that are sent out by Bridgehead are actually sent out in a way that Virtuoso can actually understand. So it needs to have a particular format, and that is done by selecting a corresponding profile in Bridgehead. Now, depending on when you downloaded the Bridget application, such a profile might already exist. So you can simply select it. If it doesn't exist, you can simply create one. Now, the way to do that is simply go into the bridge settings. And in the bridge settings, here you have under profiles, the table of profiles that are available to you. If you don't see any profile that is called Virtuoso or in a similar way, what you can simply do is you can go into the profile settings. That is done by clicking on the show file button here, and that opens up the profile.txt. And if I click on that, and let me just make that a little bit larger, oopsie, larger, not small. Then essentially you see here at the end what Virtuoso is essentially expecting is OSC messages sent under address virtuoso/quad, and then the information is sent out with the weight quaternion, or with the weight part of the quaternion first, then the Y component, the inverse X component, and the C component, and that is sent to the local computer here at port number 8000. And you can actually kind of change the port if that port is already kind of used for something else. But you need to create a profile like that, and if you once you have that, you can set that. And once you've set that, and let me just kind of click that and reset that here again, then Virtuoso should be able to receive that. So next thing, in Virtuoso, we need to enable head tracking, and the way this is done is by going into the settings, and in the settings here we have head tracking, and currently it's set up to manual. So let's set that to OSC, and if you have set everything correctly, Virtuoso should now actually receive the OSC messages, and you should see your pitch and roll change according to my head position if I turn it on. And yes, it does. Right. So if I've set up everything correctly, I should now be able to listen to my sound as if I would be in a 9.1.6 studio environment, with the audio being aware of my head position or my head movements. Now, what I always recommend is making sure that the bridge head is calibrated. So double click on that. Now, normally it doesn't really drift that much. The reason it drifts in my particular case is because of all the interference of all the things that I have here around. Normally it's actually fairly stable, but just be aware that this can drift a little, and you might need to kind of double click here once in a while, and it will actually reset that. So let's listen how our sound sounds, how everything sounds. And I might actually go back into our track and open up the Dolby Atmos Beam plugin to see where it is. So currently it is located here on the left. And you should hear the audio in exactly the same way I'm hearing that. So if I'm moving my head with the object, you will actually be able to follow that object. So currently it's on the right. It's actually slightly above. I actually even hear that it's above. Let's maybe move that down. It drifted a little, so let's... Once again, on my system it drifts a little more than it usually does because of all the interference here. And that works pretty nice actually. Now, there are a couple of settings that you can set in the Virtuoso plugin. Once again, I might actually do a special video about Virtuoso itself, because I think there are a couple of really interesting things here. You can change the head-related transfer function. You can also change ambiances. You can set EQs for different, kind of headphones, and also set certain room EQs. There are a couple of things that this plugin can do that no other plugin actually is able to do. And this is actually a really nice one. So before I finish this video, I would like to show one more thing. And if you've seen last week's video, you know that I also showed you the integration of Spacelab, which is a reverb that is from Fiedler Audio that is integrated into the Dolby Atmos Composer. Now, at the moment I'm recording this video, this is not available yet, so I do have access to an early beta version, late alpha version. So when you kind of try that out, after I release this video, this is not going to work yet, but it's going to work sometime in the very near future. So let's see how we can set that up. And there are actually only two things that we need to do. The first thing is we need to add a Spacelab plugin to a track, and it doesn't really matter which one. So what I'm going to do is I'm simply going to add that to the second one here. And let's go into our plugins here and Fiedler Audio. Once again, we're using the VST3 version, and I have Spacelab Interstellar here. I'm going to put that in here. And that should open up Spacelab Interstellar. And this is essentially a reverb plugin that allows us to send reverb into the Dolby Atmos Composer, meaning that as soon as I add a Spacelab instance to my setup, and if I open the Composer now, let's open it up again, the Composer has actually identified Spacelab as an instance, and it takes in the information that is coming in from Spacelab. So let's put our track into Spacelab, and let's kind of give it a little bit of reverb. Now, in order to route it to Spacelab, we need to replace the Dolby Atmos Beam plugin with the Spacelab Beam plugin. What I'm going to do is I'm simply going to disable the Atmos plugin here, and I'm going to add the Spacelab Beam plugin, and that will essentially beam the plugin to the Spacelab instance. So let's go back to our Spacelab instance here. Now, by default, and I talked about that last week, Spacelab does not really automatically recognize or does not really automatically add these Spacelab instances to the setup. So let's just open up the source setup and let's go to the one instance that we have. I didn't give it a name, just kind of for demonstration purposes. And this should now send the audio in connection. So let's close that and let's go back to the digital Dolby Atmos Composer. And this should now essentially send the audio with reverb to the Dolby Atmos Composer. Currently it's set to stereo, so let's switch that over to 9.1.6 because that's what we want. So let's have a listen in our digital audio workstation. Now be aware that because I switched the Dolby Atmos Beam plugin with the Spacelab Beam plugin, I no longer have an automation in the movement of the object. And before I play that, I should probably also reset the bridgehead here. So once again, this is primarily because of all the interference that I have here. There's a lot of stuff around me in a regular setup. It doesn't really drift that much. So let's go back into our... And I essentially hear the object in front of me because that is sort of where it is located. So let's go back into our Spacelab plugin, and there essentially we see that the object is a stereo object which is located in front of me. So what I can do is I maybe kind of move that in the middle and make that kind of mono. And then let's kind of play that again. I have that object in front of me. So once again, let's maybe reset the bridgehead again. Now what I can do in the Dolby Atmos Composer, let's go back into the master here. Now the signal is coming in here a little hot. So let's maybe kind of reduce the signal slightly. And in order to do that, let's go into Spacelab Beam and let's just kind of reduce the gain a bit. That should take care of that. Yeah, better now. So the interesting thing about this combination is that I can now separate the object from the reverb. And in order to do that, what I have to do is I have to push the object button here. And what that will do is it will generate an Atmos object. And this Atmos object will be run separately from the reverb. So you can think of this as the dry signal going into objects and the wet signal going into the bed. And I can actually listen to them independently. So if I'm muting the object, for example, I'm only hearing the reverb. So let's mute the object. Or I can also mute the reverb and I only have the object in front of me. And that essentially means that you can add 9.1.6 reverbs to your Dolby Atmos production in Ableton, and that's actually pretty cool. Now, once again, in my setup today, the bridgehead head track got drifted a little more than it normally does, and this is simply because of the setup here. There's just too much interference going on here. In a regular environment, this is not the case, and it actually is relatively stable. So this is really everything I wanted to say today. Thanks again for watching. Once again, there's a second part of this video coming up where I'm going to talk about how to do the same things in Windows. Now in Windows, we need to work around a couple of Windows quirks, unfortunately. So things are a little bit different in Windows, but they work just as nicely. Just a little bit more than I need to talk about, so I couldn't kind of squeeze that into this video. But that video is going to come up either next week or the week after that. And meanwhile, if you have any questions or comments, please use the comment section below or join my Discord community. Invite link is in the description below. And with that being said, see you at the next video.